Differentiating natural log functions, example 1. We're asked to find the derivative of these two log functions. In the formulas and tables book, we see that the natural log of x, when we differentiate it, goes to 1 over x. Each of these examples are a bit more complex. X has been replaced by some function of x, so therefore we're going to use the chain rule. So in the first example, the derivative of the natural log of 4x squared plus 1 would be 1 over 4x squared plus 1. That's the derivative of the outside function, the natural log, multiplied by the derivative of the inside function. The derivative of 4x squared plus 1 is 8x. This is our solution. We just might write it in a neater form here. In example 2, we have a composite function again with 3 levels to it. There is the natural log, there is the square of sine x. The inside layer is the sine x, the next layer is the squared, and then the natural log is the outside layer. So the diff of the outside is natural log of sine squared x, which will be 1 over sine squared x. Next, we're going to differentiate the sine squared x. So that's sine x to be squared. So this becomes 2 times sine x reduced to the power of 1 is to the power of 1. And lastly, we're differentiating sine x itself. That's the inside layer. And sine x, when we differentiate it, gives us cos x. Now, this is our solution. We just want to neaten it up. We notice we're dividing by sine squared x and multiplying by sine x. So sine x goes into sine squared x once, leaving us 2 cos x divided by sine x. Now, cos x divided by sine x is cotan x, or cot x. So 2 cot x is our final answer.